All right. Here we go. So for domain, well, before we fill in these blanks, get it right. No, just kidding. Here we go. All right. So this is notice the picture I have up here is number 1 on that handout I gave you. Okay, it's a graph. First question, is this a function?
Yeah.
Argument vega. Right. Perfect argument. It passes the vertical line test. That's a perfect way to say it. It passes the vertical line test. Now, the domain and range, we actually defined 3 days ago, if I'm not mistaken. Or actually last Friday, I think it was. Anyway, the domain is every value that x can be, or every value that the input can be. So watch this. Watch this. Every value that the input can be. Let's see. What would be the input right here? What would be the input value here? So what would be the input value right there? 4, huh? Just 4. Right now I don't care about the output. What would be the input value right there? -5. Right? Just the input. Input is just the first coordinate, not the output. I don't care about the output right now. Just right now I'm focusing on the input values, which is what the domain means. The domain is asking, look, what are the possible input values for a function? What are the possible input values for a function? Okay, so far -5. What does this arrow mean? Yeah, it goes on forever this way. So if it goes on forever that way, that means I'll have input values that are way bigger than, or actually I should say way lower than -5. Let's see here, -5, -6, -7, -8. This might be like a -8 input, but it keeps going. -9 input. Look at my hands over here. -10, -12. If it keeps going, that means the input can be any negative number to what's infinitely that way? What's infinitely this way on the x-axis? Infinity, negative infinity, yeah. So x can be any number to negative infinity. Think about that. How about this over here? We got another arrow here, right? That's going forever that way. Right here it's 4, right here it's 5. If I keep doing 6, 7, 8, 8 something, 9 something, 10 something. So positive infinity and negative infinity, x can be any number from negative infinity to positive infinity. Therefore, the domain is, ready? Put all real numbers. Say again? No. Fake numbers are not called fake numbers, they're called imaginary numbers. So when I say a real number is a number that you can see on the number line. Like 1/2 or 1, -5. Those are all numbers that you can imagine somewhere on the number line. That's what a real number is. So all I'm saying is, look, x can be, for this function, x can be any real number. Any number on the number line. X can be -50. So if I come down, x can be -50, the output value will be way up there because this is going way up there. But the input would be -50, output up there. X can be positive 100. Positive 100 would be about right here. The output would be way up there because that's going that way. So right now the domain is all real numbers. Okay. How about the range? Coming to a theater near you. That's coming next week. A way of communicating domain and range. Yes. My bad. Here we go. All right. How about the range? One more time. Would it be the opposite? Let's see. The domain, or actually the range, would be all the output values or the y coordinates. So let's see. Now I'm looking at the y values. Let's see, here's 2. So look at, here's 1, 2. Look at y can be 2 here, and y can be 2 right here. All right? How about 3? Y can be 3 right here, and y can be 3 right here. Can y be 1? Yeah, look at right here and right here. Whatever these coordinates are, there's a y value. X something, and this would be 1, 2. Y would be 3. Here, x is something, y is going to be 2. X is something here, y is going to be 1, right? This one, y is going to be 1. The output's going to be 1. The output's going to be 2, and so on. Is there any y values that y cannot be, according to this graph? Which ones? So look at, can y be -2? Yeah, look at right here. It's still on the graph. Y would be a -2 value there. So I'm looking at the y-axis only. But anything beyond, right, anything lower than this point right here, y is not going to be those values. Y is not going to be anything lower than -2. Y is only going to be anything from -2 and above. Think of the logic there. So the range then, look at the way I'm going to write the range. I'm going to state all the values y can be on this function. Look at what I'm going to write. Y is greater than or equal to -2. What am I saying here? The y values of this function can only be numbers that are greater than -2. Look, that means this. Here's -2 on the y. Look, I'm looking at the y-axis here. Greater than -2, that means up this way, or equal to -2. Look at it can be this point, -2. In this case, it would be 0, -2. So y can be -2 or anything higher. That's what this means. So maybe underneath here, y can be any value greater or equal to -2. That's what domain and range mean. X's, the domain can be any number you want it to be. But y, the y values can only be -2 and higher. So I use the red marker for domain. When I looked at the domain, I just looked at the x-axis. And I was asking myself, what values can this function be for x, just the x number line? On the domain, I just looked at the y-axis, and I asked myself, what values can y take on? Just looking at the y-axis. Okay, so now going back to the top of that paper that I just passed out. For domain, watch this. For domain, scan your pencil, so the pencil in your hand or pen, scan your pencil left to right along the x-axis. Write that in there. For domain, scan your pencil left to right along the x-axis. For range, scan your pencil bottom to top, because you're looking at the y-axis, along the y-axis. Up and down is cool. But we want to start from the lower values to the higher. Down and up, yeah. Okay. Question? Okay. Now, think back on our thug example over here. Think back on our thug example. Last week. Here's the function, right, for our thug. F equals 4s. We graphed it for a warm-up, I forgot how many days ago. Let me put the graph up here. So why is domain and range, what's the big deal? But why are we talking about domain and range? Why do mathematicians care about what values x can be and what values y can be? Well, here's why. Domain. What's the domain of the function that describes the thug? What are the possible x values for the thug? Right. So was there such, what did the x-axis represent for our thug again? The speed. Actually, careful. S stood for seconds, so it stood for time. So is there such thing, when we wrote the function for the thug running away from the lady, is there such thing as negative seconds? What would a negative second look like? So this is negative seconds? That's going backward, but I want to know what a negative second looks like. Can someone show me, please? Like, can someone do them? I don't know. I like that. So for this function that describes the thug running away, the domain is x can be, watch this, x can be 0 or, are these bigger than 0, those values? Yeah, so x can be greater than or equal to 0. So you don't have to write that down. I'm just right now, I'm focusing on why talk about domain. Who cares? Domain sounds boring. Who cares what x values can be? Well, in real life, if a scientist is going to throw an equation on a certain phenomena or something that's going on in reality, like planetary motion or the eclipse on Monday that we're going to see, the scientist will say, look, let me describe mathematically the thug. The thug's the equation is F equals 4s. The domain is this. That means for any, I should say s, huh? Not x now. Seconds can only be greater or equal to 0. And so he's actually defining this function. He's defining it for this thug, what's really going on. This describes his running away from the lady, and this describes what values x can take on. S can be anything bigger than or equal to 0. How about the range? Now look at the y-axis. Is there any values? Well, what does the y-axis represent? Feet, huh? So we'll call this the f-axis. Is there any feet that doesn't make sense in this situation of the thug? Right, negative feet, huh? There's no such thing as negative feet away from any distance, from any point in space. So if I stole Vega's purse, pretend, let me just pretend. So, if I run this way, That's still a positive distance. Let me take her backpack. If I run this way, that's still a positive distance. No matter which way I run, it's still positive distance. So, well, go ahead, someone on the input. So negative feet makes no sense in this situation. So the range now, look at the f-axis. Feet can only be what? Right, same thing. Look at it. So this, look at this, fully describes the thug running away. I gave you the equation. I gave you what values S can take on and what values F can take on. So in the real world, when scientists give an equation to describe something, they give the equation and the domain and range. So it gives context to another scientist who's like doing research on his work or reading over his work. He understands what's going on. What do you think, Barry? Let's do one more example and we're done. Look at that second example in the handout, number 2. You guys are doing good for a Friday, I must say. I must say. Look at this one. All right. Is this a function? Argument. It doesn't pass a vertical line test. Right here, right? 2 points. Not a function. It's still a relation, though, so we can still describe the domain and range of a relation. It's a relation, but it's not a function. All right. What's the domain here? What are the possible x values for the domain? So now look at the top of the page. Scan your pencil from left to right. So I'm going from here. I keep messing up here. From here to here, and I'm asking myself, what are the possible x values? Can x be over here? No, 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 no. Yes. X can be here. Is that all x can be? -3 and 3? Well, what about right here? There's still an x value there. What about right here? What about right here? Here, here, here. Look at all these values. What are these values? No. Look at, so this value would be, look at x right here. What would x be for this point? Careful. 2. And what would y be? -2. So far, x can be, look at, from left to right, x can be -3. Can x be this value? Yeah, look at right here and right here. X is right here and here. So x can be any of these values here. And it stops right here. So how would I write that as a statement, a mathematical statement? Go ahead. Anything what? Oh, that would actually, there's actually an infinite amount of points in there. Because, hold that thought. You just want to finish, huh? Gomez just wants to finish. Just put some. Let's go on. Let's see. What's the x value there? -2. Up 2. So let's see. X can be right here. X can be -3. 0 there. So look at x can be -3. X can be -2. X can be here -1. X can be 0. Look at right here. X is 0. Y is something right here. X can be here +1 and then something. X can be +2, then something. And then right here, x can be +3 and then something. So look at -3, -2, -1, 0, 1, 2, and then 3. Okay, so x can be any number between -3 and +3. Brackets we'll touch on next week, but I like how you're thinking. Remember the Pac-Man symbols like we just did? Watch this. X can be, look at this, greater than or equal to -3 and less than or equal to +3. There's a domain. Write that down. Well, look at the Pac-Man wants to eat what's greater. So this is x is greater than -3. X is greater than or equal to -3. What else is it? What else is x? X can be any number less than or equal to +3. If you look at all these values on this circle right here, here, and here, the x value is going to be in between -3 and +3 on that circle. So x is greater than or equal to -3 and that's the key word, and. It's two things at one time. It's greater than or equal to -3 and less than or equal to +3. Now, this arrow, hopefully your elementary school teacher said, pretend it's like Pac-Man. Pac-Man always wants to eat what's bigger. So if x is on this side of the Pac-Man, x is less than 3. 3 is greater than x. So to read this statement, x is, look at, greater than or equal to -3 and less than or equal to +3. What's the matter with Gomez? Someone give him a hug. Yeah. There's a pattern. Right. So what is x? What can x be? When we ask the domain, we're asking what can x be? What can it be? It can be equal to -3 and then greater. Look, because -2 is actually greater than -3 because anything that way is greater. Right? Yeah. Sure. How about range? How about range? Same thing, huh? Let's see. So range, I'm just looking at the y-axis now. What can y be? Same thing, I look at, on the y-axis, this is -3. Actually, this should be the second coordinate. Something, -3. Something, +3, actually. Same thing. So the y values can be anything in between here. So this is, all the y values are between -3 and +3. So look at the way I'm going to write it. Y is greater than or equal to -3 and less than or equal to +3. That's it for today. We're going to continue this on Monday. Okay?